Welcome to Messy Math Moments Matter, where we explore experiences to help students engage in math more deeply. When we allow opportunities for math to get a little messy, we will see big results. Don't worry about it being perfect. Math class should be perfectly imperfect, just like this video. So for this experience, we are going to focus on grade 4, organizing idea number, learner outcome number 5. Students apply equivalence to the interpretation of fractions. So I've gone ahead and I've highlighted the cusps that I will be specifically focusing on for this experience. That doesn't mean I won't touch on some of the other ones, but they're not as deliberate of a focus as I'm intentionally doing here. So for the understanding, there are infinitely many equivalent fractions that represent the same number. These are the knowledge pieces students need to know, and the skills and procedures, the things that students will do in order to build this understanding to work their way towards this particular learner outcome. The next piece is to take a look at the special care and attention. There are two clarifications that I want to address. Number one of the cusps states that decimals can be expressed as fractions with a denominator that is equivalent to the place value of the last non-zero digit of the decimal number. Now, there is a danger in the way that this is phrased. What they are trying to talk about is 2/10 or 3/100, that you'll always be able to write it as a decimal. But 2/3 and 1/3 and 2/6, you can't write it in that kind of a format. So this kind of implies that every fraction you ever do will always work in that format, which we know is not true. In grade 4, however, we are living in that world of fractions that will nicely work their way to decimals for conversions there. So just be careful of that. Just say something like many decimals can be expressed as fractions in this way. The second clarification I want to bring up is that one of the learner outcomes talks about ordering fractions, decimals, and percents, but the idea is that it's limited to ones that will nicely convert, and they're already out of tenths or hundredths, not 3/4 compared to 25%. So you want to keep that in mind. Those would be considering excelling because you'll be pulling in multiple different learning outcomes. But if you're looking for proficient or satisfactory understanding, you'll be limiting it to nice, easy fraction to decimal to percent comparisons. Why this lesson? Students will explore equivalent representations of 1/2 using relational rods and connect those representations to a number line. This lesson builds upon the grade 3 lesson, and which I've linked in the teacher instructions, which is focusing on 1/2 in different wholes and putting those on number lines. So if students haven't worked a lot with relational rods, in particular with fractions, you might want to go and start with that one. What materials will you require for this? Well, you'll need relational rods, and they'll have had to have prior experience with those. I've linked the slideshow in the teacher instructions that you can use with this, and it's slides 1 through 15, plus the slide at the end that will be the number line handout. So it's the last slide in there. So this is the handout that you will be using. Now, when you open up the slideshow, you will see there's another version of the number lines where it is horizontal style, and there's a lot more of them. But what I found was that students, when they're using relational rods, need more space in between in order to build those and trace them on here. And the other one, because they're so much closer together, wasn't as good. So I chose to use this one, which is printed in portrait style, and it gives a lot more space between each number line for those tracings. You'll notice that here it does say slides 1 through 15 plus the last slide. That's because slide 16 and the rest of them are all other visuals of student handouts that you could use with students after they've experienced this particular experience. I obtained those through NCETM. They have a really nice fractions section, and they give permission for you to use those and recreate those and adapt them. So I created our own version, pulled out only the ones that apply to Alberta curriculum, And the ones that apply to equivalent fractions, I put inside the slideshow. So there are screen captures of those, but in the teacher guide, you will also have the option to access the original. So you can go ahead and print those off for students. They can work on them in partners to build further understanding in here. I've also included the link to where you can get the original from so that you can see what the originals were and you can access any other pieces that you might want from that. Okay, let's go ahead and get started with the experience. The first thing that you're going to do is take the black rod and place it horizontally in front of you, like the horizon. Now your job is to try to create another layer. And when we create the layer, we're going to place it on the paper, but touching the black rod, not on top of the black rod. Find 2 rods that will make this same length, but the rule is you must have 2 rods and they must be of the same color. So I couldn't use, for example, a green one and a blue one. A, they're not the same length, but B, they're not the same color. I could not use 3 blue ones because even if they were the same length, I'm not using exactly 2 rods. So the more experience students have with relational rods, the faster this aspect will go. The less experience they have, obviously, it will take them more time to figure out the answer for this one. But eventually they will figure out that 2 purple rods will fit the criteria. So exactly 2 rods, 1 color. So my question to students will be then, I'm just going to take one of these away. What is the relationship between 1 purple rod and the black hole? Well, they figure this out pretty quickly that it has a relationship of 1/2. Now this is all part of the grade 3 experience, so they should be quite familiar with this part, but the purple is one of the 2 equal parts that I needed to build the hole. So I needed 2 to make the whole line, the rod that was equivalent, but I only have 1. So 1 of the 2 equal parts. We name that as 1/2. So now what I'll have students do is take their handout and we'll place this on their handout. And I reinforce the fact that this line needs to be, it's their starting line, so it needs to be on the left-hand side, and that this needs to be done super neatly. So when I place the black rod on there, I need to make sure it lines up perfectly with that black starting line. And I will go around and make sure students have lined that up. And when they have done that, they will trace very neatly above and below the line. From the start to the end, this is 1 hole, and we will label this as 1. This is my start, so I want to neatly label that as 0. So from here to here, that's my hole rod, and I can place it back there to make sure from here to here, that's my hole. Now I'll take my purple one, and it's going to go on top of the number line. Again, making sure it's neatly lined up to the left-hand side. And I'm going to move my black rod out of the way to make this easier. I'm very neatly going to trace. So the easiest way to do it is to trace along the rod, remove the rod, and bring it down. And this is 1/2. 1 from here to here, that's 1 of the 2 equal parts I needed to make the whole black one. If I were to take my other purple rod and place it there, I would now have from here all the way to here, I would have 2 of the 2 parts I would need to build the whole thing. From here to here is 1. From here to here is 1/2. From here to here, how much is this? Well, that's 1/2 as well. So these numbers here tell you the distance from 0 from the start. All right, task number 2. I have a purple rod and I've got a black rod. What I actually want to do is recreate this so it's exactly the same, but I'm only using purple rods. What might that look like? And I would give students some time to figure that out. Again, if they work through the grade 3 lesson, they've done this process again. It's kind of a repeat. Some students might struggle with this. So in this case, what I might say is I'd like you to build on top of these rods, but only use purple ones. So then they can place on top purple one, a purple one, and a purple one. Because what I notice happens sometimes is they start to build odd shapes. And the only way I could get them to see that it needed to be exactly the same was having them build it on top. Once they've built it on top, they will just take it off and build it beside. There we go. So I built the exact same one, but only using purple. So what's the relationship between the purple rod to the bottom? Well, it's still only 1/2. Let's go ahead and trace this. We'll take my hole, place it on here. I'll trace it neatly. And that is my hole. And here is my start. And then this one, neatly placed on here. And I could remove my bottom one too. Might be easier. Place it on there, trace it down, trace it further down. And that is one of the 2 equal pieces. And again, I can place my hole back here, place my 1/2, and then I'll place another one here. From here to here is 1. From here to here is 1/2. So I've got 1/1/2, and I've got a second 1/2, which we name as 2 halves. Here's your next task. I want you to recreate this again. And again, you're only allowed to use one color. So this one we only use purple. So now find a different color other than purple to recreate this. What does it look like? Again, students might have to build on top, but when they're ready and they've found them all, you should end up with this representation of rods using blue. And this representation of rods using green. So now I would ask students, if I have this one and this one, so this one has a black as the whole, and this one has only purples, so it is purples as the whole. What if I were to recreate this one like that? Does that make sense? Does this still represent a 1/2? From here to here, that's a 1/2 of that whole. What if I did the same thing for my green one? Does that still represent this one? Just differently. This one is all of the green ones marked, and this is one whole. Does this still represent a 1/2? So getting students to see the relationship between those. I'm just going to move these out of the way for now. Now let's go ahead and trace these. So I'm going to take my blue representation, and first I'll start with my hole. Again, super important for this to be neat. Now what happens, we know to be true, is that these plastic rods sometimes are a millimeter out, so it might be just a hair's breadth out. So just remind students of that. But here's my hole. And this is my 1/2. Okay, I'm just going to move these out of the way so I can trace these. But when I take a look at this, I see other options for tracing. I see a line right here I could trace if I was starting at the top. So I'm just going to move these out of the way for a moment. And I'm going to trace that line. And I'll just take this out of the way and I'll put this back. So how would we name that? Well, that is one of the 4 parts I need to build the whole thing. So that would be listed as, let me just move it so I can see my line, 1 of the 4 equal parts I need to build the whole. Notice I put it a little bit below that 1/2. I put this back. how would I name it if I put a second one here? So I've got 2 of the 4 equal parts. I've got 2 1/4. I have 2 fourths. So we'll label this one as 2 fourths as an alternate name. Let's add another one. Oh, I need to trace it. Well, this one would be 1 of the 4, 2 of the 4ths, 3 of the 4ths, 1 1/4, 2 1/4, 3 1/4. 3 of the 4 equal parts needed to build the whole. Okay, and the last one is 1 1/4, 2 1/4, 3 1/4, 4 1/4. 4 of the 4 equal parts needed to build the whole. And remembering that this is the distance from 0. This is 1 of the 4 from 0, 2 of the 4 from 0, 3 of the 4 from 0, 4 of the 4 from 0. So when I remove this, I can see I could name that as 1/2 and 1. I could name this as 2 fourths and 4 fourths. We're going to repeat the exact same procedure using the green ones. Now the green ones are trickier because they're so much smaller. So I'm going to go ahead and trace out all my lines and then we'll come back for naming them. All right, so I've labeled them. I started out here and then when I hit 1/2, I kind of went a little wonky and went down. I usually try to keep them on the same line, but that's fine as long as they can see it. So then I can ask students to go ahead and look for relationships. What's the same, what's similar, what's different amongst these 4 number lines? So they might say, well, the ones are all here, the starts are all here. There's halves that all line up. But look at the halves. This one is a half, this one is a half, this one also says 2 fourths. And this one says 4/8. Oh, I noticed that 4 is half of 8, 2 is half of 4. When I look at the wholes, I see 2 halves, I see 2 halves, I see 4 fourths, 8 eighths, because I need 8 equal parts in this one. They might say, when I look here, oh, look, these 2 lines match up. 1/4, 2 eighths, 3 fourths, 6 eighths. And then I see that these ones don't match up. Now, what I might do is say to students, okay, what if my whole, I had another rod that if I could put 12 of them here to be equivalent in length to this whole? What would that look like? So they could trace out the whole and they would say, well, 12 needed to make the whole. So 12 of the 12 would be there, 0 would be here. Well, which ones could you figure out? Well, they might use some sense making, and I would do this with partners, sense making and say, well, this one is halfway. So half of 12 parts is 6 parts. So that'd be 6 of the 12. What else could you figure out? Well, this would be approximately, maybe a little bit more. There we go. That looks better. Why did you change that? Well, because I know that halfway here would be like the same as halfway here and halfway here. So I need my lines to match up. So this is my better version of that line. Okay, well, what would it be? How many of the 12 parts would there be? Well, it'd be half of 6, so it'd be 3. Well, what else could you figure out? Well, I could figure out here is halfway between half and 1. Halfway between 6 and 12 is 9/12. Are there any other ones you could figure out? Well, I know the pieces would be about that size, give or take. Well, what would the distance be here? There'd be 1/12, 2 1/12, 3 1/12, 4 1/12, 5 1/12. And students could fill this in. Just sense making, just approximating what that would look like. And then you could say, what about 24? Or any multiple that would work nicely with these numbers where they could previous ones to help them figure it out. So I like sticking with even numbers. In this case, 24 would be great because they could half all of the 12s into smaller amounts. 16 would be okay because then I could use the 8s. 20 would be okay because then I could use the 4s. Things like that. But don't jump to 15 because trying to make 15 work would just be messy. At this point, I could then go to my teacher instructions, grab those handouts from the slides that you see from slide 16 and on, and use those with students. They could work with partners and then eventually work on their own on some of those. So hopefully you found this helpful. If you have any ideas for future Messy Math Moments Matter videos, I would love to hear from you. Looking forward to seeing you in the next one.